When constructing a temporary power station for Christmas lights, several key factors should be considered to ensure safety and reliability. Firstly, it is critical to ensure proper circuit protection. Each circuit should have its own dedicated 15-amp circuit breaker. The main power supply should also have an appropriate circuit breaker or fuse protection. Secondly, proper grounding is essential. A single community ground is acceptable for the bell boxes, but ensure the ground rod is properly installed and the connections are secure. Outlet covers and use covers are a good practice to prevent exposure to moisture or accidental contact. Panel mounting. The electrical panels should be securely mounted within the polyvinyl chloride box to prevent movement or moisture ingress. Cord selection. The SJ06/4 cord is appropriate for the main power supply, but verify that it is the correct gauge for the current draw of the lights. The electrical inspection. It is recommended to have a licensed electrician inspect the installation before using it. Safety measures. Keep the pyramid away from flammable materials and ensure there is adequate ventilation to prevent overheating. Maintenance. Regularly check the electrical system for any damage or loose connections. Additional considerations. Consider the power factor of the lights, as this can affect the current draw and circuit loading. Calculate the potential voltage drop over the length of the power cords and adjust the circuit breaker ratings accordingly. The pyramid should be weatherproof to protect the electrical components from rain, snow, and other elements. Storage. Store the electrical components in a dry and protected area when not in use. Considering circuit protection in more detail, it's important to understand how circuit breakers function. Circuit breakers are designed to protect electrical circuits from overcurrents, which can result from short circuits or excessive loads. A 15-amp circuit breaker is intended to trip or disconnect the circuit when the current exceeds 15 amps. Using appropriately sized circuit breakers is crucial to prevent overheating of wires and potential fires. For the main power supply, the circuit breaker or fuse should be sized according to the capacity of the wiring and the connected load. Consult the National Electrical Code, or NEC, for guidance on selecting the correct size circuit breakers and fuses. Proper grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to return to the source, allowing the circuit breaker to trip and energize the circuit. A properly installed ground rod provides a low impedance path to earth, which helps to minimize the risk of electric shock. The ground rod should be made of a conductive material, such as copper or copper-clad steel, and should be driven into the ground to a sufficient depth to ensure good contact with the earth. All ground connections should be secure and corrosion-resistant. In-use covers for outlets are important for preventing moisture and accidental contact, especially in outdoor environments. These covers are designed to protect the outlet from rain, snow, and other elements which can cause short circuit or corrosion. They also help to prevent accidental contact with live electrical pots, which can result in electric shock. When selecting in-use covers, make sure they are rated for outdoor use and are compatible with the type of outlets being used. Securely mounting electrical panels within the polyvinyl chloride box is essential for preventing movement and moisture ingress. The panel should be securely fastened to the box using screws or other appropriate hardware. The box should be sealed to prevent moisture from entering, which can damage the electrical components. Ensure that the box is rated for outdoor use and is made of a durable material that can withstand the elements. When selecting a cord for the main power supply, it is important to verify that it is the correct gauge for the current draw of the lights. The gauge of the wire refers to its thickness, and a thicker wire can carry more current than a thinner wire. Using a wire that is too thin for the current draw can cause the wire to overheat, which can lead to a fire. The NEC provides guidance on selecting the correct wire gauge for different current levels. An electrical inspection by a licensed electrician is highly recommended before using the temporary power station. A licensed electrician can inspect the installation to ensure that it meets all applicable electrical codes and safety standards. They can also identify any potential hazards or problems and recommend solutions. Keeping the pyramid away from flammable materials and ensuring adequate ventilation are important safety measures to prevent overheating. Electrical components can generate heat, and if they are not properly ventilated, they can overheat and potentially cause a fire. Flammable materials, such as wood or paper, should be kept away from the electrical components to prevent them from igniting. Regularly checking the electrical system for any damage or loose connections is essential for maintaining its safety and reliability. Damage to the wiring, outlets, or other components can create a safety hazard. Loose connections can cause arcing, which can generate heat and potentially start a fire. Inspect the system regularly and repair any damage or loose connections promptly. Considering the power factor of the lights can affect the current draw and circuit loading. Power factor is a measure of how efficiently electrical power is used. A low power factor can cause the current draw to be higher than it needs to be, which can overload the circuit. If the lights have a low power factor, consider using power factor correction capacitors to improve the power factor and reduce the current draw. Calculating the potential voltage drop over the length of the power cords is important for ensuring that the lights receive the correct voltage. Voltage drop occurs when the voltage at the end of the cord is lower than the voltage at the source. Excessive voltage drop can cause the lights to dim or not function properly. The amount of voltage drop depends on the length of the cord, the gauge of the wire, and the current draw. Use a voltage drop calculator to determine the potential voltage drop and adjust the circuit breaker ratings accordingly. Weatherproofing the pyramid is essential for protecting the electrical components from rain, snow, and other elements. Use weatherproof enclosures, connectors, and wiring to prevent moisture from entering the electrical system. Apply a sealant to any cracks or openings to keep out water. When storing the electrical components, keep them in a dry and protected area. Moisture can damage the electrical components and create a safety hazard. Store the components in a container that is sealed to prevent moisture from entering. Consider using a desiccant to absorb any moisture that may be present. By following these guidelines, you can ensure that the temporary power station for Christmas lights is safe, reliable, and compliant with applicable electrical codes. Furthermore, let's elaborate on some of these points. Firstly, regarding circuit protection, it's important to distinguish between different types of circuit breakers. There are standard thermal magnetic circuit breakers, which trip based on thermal overload and magnetic short circuit detection, and there are ground fault circuit interrupters, or GFCIs, which protect against ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person. GFCIs are designed to trip very quickly in response to even small ground faults, which can prevent electric shock. The use of GFCIs is required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. Secondly, in regards to proper grounding, it's important to understand the difference between grounding and bonding. Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting different metal parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. The NEC specifies the requirements for grounding and bonding in detail. Thirdly, concerning outlet covers, there are different types of in-use covers available. Some covers are designed to be weatherproof when an electrical cord is plugged into the outlet, while others are not. Choose the appropriate type of cover for the specific application. Additionally, some covers have a locking mechanism to prevent unauthorized access to the outlet. Fourthly, with respect to panel mounting, ensure that the polyvinyl chloride box is properly sized to accommodate the electrical panels and wiring. The box should have sufficient space to allow for proper ventilation and to prevent overcrowding of the wires. Overcrowding can lead to overheating and potential fires. Fifthly, regarding cord selection, consider the length of the cord when selecting the wire gauge. Longer cords will have a greater voltage drop than shorter cords, so a thicker wire gauge may be required for longer cords. Use a voltage drop calculator to determine the appropriate wire gauge for the specific application. Sixthly, concerning electrical inspection, a licensed electrician can also perform other important tests such as a ground impedance test and an insulation resistance test. The ground impedance test measures the resistance of the grounding path, while an insulation resistance test measures the resistance of the insulation on the wires. These tests can help to identify potential problems that may not be visible to the naked eye. Seventhly, with respect to safety measures, ensure that the pyramid is located away from any water sources, such as sprinklers or rain gutters. Water can conduct electricity and create a safety hazard. Additionally, keep children and pets away from the pyramid to prevent them from tampering with the electrical components. Eighthly, concerning maintenance, regularly check the outlets and cords for any signs of damage, such as cracks, frayed wires, or loose connections. Replace any damaged components immediately. Also, clean the electrical panels and boxes regularly to remove any dust or debris that may accumulate. Ninthly, regarding power factor, a low power factor can also increase the cost of electricity, as the utility company may charge a penalty for low power factor. Improving the power factor can reduce the cost of electricity and improve the efficiency of the electrical system. Tenthly, concerning voltage drop, excessive voltage drop can also damage electrical equipment. Electrical equipment is designed to operate within a specific voltage range, and if the voltage drops too low, it can cause the equipment to malfunction or fail. Finally, with respect to storage, store the electrical components in a location that is protected from extreme temperatures and humidity. Extreme temperatures can damage the electrical components, and high humidity can cause corrosion. In addition to these points, it is also important to be aware of the applicable electrical codes and safety standards. The NEC is a widely adopted electrical code that provides detailed requirements for electrical installations. Consult the NEC for guidance on all aspects of the temporary power station, including circuit protection, grounding, wiring, and safety measures. It is also important to comply with any local electrical codes or regulations that may be in effect. Always prioritize safety when working with electricity. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Remember, safety is paramount. Never compromise on safety to save time or money. A well-designed and properly installed temporary power station will provide safe and reliable power for Christmas lights for years to come. By following these guidelines and consulting with a licensed electrician, you can ensure that the temporary power station is safe, reliable, and compliant with applicable electrical codes and safety standards. Let's delve deeper into the specifics of some of these critical elements. First, let's consider the nuances of circuit breaker selection. It is crucial to select circuit breakers that are not only rated for the appropriate amperage, but also have the correct interrupting rating. The interrupting rating is the maximum amount of fault current that the circuit breaker can safely interrupt. If the fault current exceeds the interrupting rating, the circuit breaker may fail to trip, which can lead to a dangerous situation. The interrupting rating is typically marked on the circuit breaker. Second, let's examine the intricacies of grounding electrode systems. A grounding electrode system consists of one or more grounding electrodes that are connected to the electrical system. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC specifies the requirements for grounding electrode systems, including the type of electrodes, the size of the electrodes, and the methods of installation. Third, let's consider the different types of in-use covers available. There are horizontal in-use covers, which are designed for outlets that are mounted horizontally, and there are vertical in-use covers, which are designed for outlets that are mounted vertically. There are also adjustable in-use covers, which can be adjusted to fit different types of outlets. Choose the appropriate type of cover for the specific application. Fourth, let's analyze the factors involved in selecting the appropriate size polyvinyl chloride box. The size of the box depends on the number of conductors that will be installed in the box, as well as the size of the devices that will be mounted in the box. The NEC specifies the minimum box fill requirements, which are based on the volume of the box and the size of the conductors and devices. Fifth, let's discuss the different types of electrical cords available. There are service cords, which are designed for heavy-duty applications, and there are extension cords, which are designed for lighter-duty applications. Service cords typically have a thicker insulation and a higher current carrying capacity than extension cords. Choose the appropriate type of cord for the specific application. Sixth, let's elaborate on the importance of performing insulation resistance tests. An insulation resistance test measures the resistance of the insulation on the wires. Low insulation resistance indicates that the insulation is damaged, which can lead to leakage current and potential electric shock. Insulation resistance tests should be performed regularly, especially on older electrical systems. Seventh, let's consider the safety precautions to take when working with electricity. Always to energize the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. Eighth, let's examine the different types of electrical connectors available. There are wire connectors, which are used to connect wires together, and there are cable connectors, which are used to connect cables to electrical equipment. Wire connectors are available in different sizes and types, depending on the size and type of wires being connected. Ninth, let's discuss the importance of maintaining a clean electrical system. Dust and debris can accumulate on electrical components, which can lead to overheating and potential fires. Clean the electrical panels, boxes, and components regularly with a vacuum cleaner or a soft brush. 10th, let's consider the environmental factors that can affect electrical equipment. Extreme temperatures, humidity, and corrosive substances can damage electrical equipment. Protect the electrical equipment from these environmental factors to extend its lifespan and maintain its reliability. Furthermore, understanding the nuances of grounding and bonding is paramount. Grounding ensures a safe path for fault current to return, tripping the breaker, while bonding connects metallic parts, minimizing voltage differences and shock hazards. Consult NEC Articles 250.4 and 250.9 for detailed requirements. Also, choosing the correct wire gauge is essential. Undersized wires overheat and cause fires. Refer to NEC Table 310.15 for opacity based on insulation type and temperature rating. Account for ambient temperature and conduit filtering factors per NEC 310.15b2 and 310.15b3 respectively. And using GFCIs is critical in wet locations. They detect ground faults tripping rapidly to prevent electrocution. NEC 210.8 mandates GFCI protection in bathrooms, kitchens, and outdoor areas. Test GFCIs monthly to ensure proper functionality. Lastly, proper overcurrent protection prevents wire overheating and insulation breakdown. Breakers should be sized per conductor and opacity, protecting against overloads and short circuits. Use time delay fuses for motor circuits to handle inrush current without nuisance tripping, referencing NEC 240.4 for conductor protection. These considerations, rigorously applied, ensure a safe and reliable temporary power system.